Welcome children. Now as we are aware of the concept of composition of functions and how to ensure that a function will be invertible or not, we can try some questions based on that. This is question number 4 from exercise 1.3. According to the question, a function fx is given as 4x plus 3 over 6x minus 4 provided x is not equal to 2 by 3, as it will reduce the denominator into 0 and the function takes indeterminate form. So x can be any real number other than 2 by 3. Under this condition, we need to prove that composition of f with itself will be equal to x. Okay. Again, x is not equal to 2 by 3. Once we are able to get this result, we have to make out what will be the inverse of f. Now see here, composition of f with itself is possible because over here the nature of x is a real number. So f is from real numbers to real number, where the elements in the domain which are real numbers will not contain one of the real number, which is 2 by 3. So the domain is all real numbers except 2 by 3. Fine. So that this does not reduces to 0, the denominator. Now we will see whether f of f can be proved to be equal to x or not. Now see here, when we calculate the composition of f with itself, we can write it as f of fx. Because fx is known to us, we have substituted the value of fx here. Now it is again image of this entire term under the function f. Now under the function f, the image of x is equal to this expression. Now in place of x, here we are having the expression 4x plus 3 over 6x minus 4. So you apply the definition of fx. What we need to do is, we'll replace x by this entire expression in the right hand side. So it becomes f of this function, f of this expression becomes, or you can say under function f, the image of this expression or the number it will reduce to will be 4 times this number, which is 4x plus 3 over 6x minus 4. See, this is 4x. X means the number which is appearing here. So over here in place of x, we have 4x plus 3 over 6x minus 4. So 4 times that number plus 3 divided by 6 times the same number minus 4. Now simplifying it on taking LCM, you can see 6x minus 4 in both the denominators gets eliminated, and LCM you can take quickly and it reduces to 16x plus 12, and then 3 multiplies with this, we get 18x minus 12. In the same way in the denominator we get 24x plus 18 and then minus 24x plus 16. So you see here plus 12 minus 12 gets eliminated, 24x and minus 24x, and the sum in the numerator reduces to 34x. That in the denominator is simply 34, which comes out to be x. So we could show the composition of f with itself is coming out to be x. If you can recall the definition of composition of functions, and using that when we defined inverse of a function, the condition was for a function f which is from x to y, if we are able to show that there exists a function g from y to x such that composition of f and g comes out to be an element from the domain of f. You can see the elements in the domain of f are denoted by x. In the same way, composition of g and f comes out to be an element from the domain of g. Then they are termed as inverse of each other. Over here we have taken composition of f with itself. Okay, and the element is coming out to be an element from the domain of f itself. So f of f is coming out to be an element from the domain of f. This is the notation we use for it. Okay, so what can we conclude from here? It means f is invertible. See, if you assume this f to be g, though f and g here are same, then whether you write f of g or g of f, it will come out to be same. So we can say f is invertible where f inverse will be equal to f itself. Okay. So inverse of f here comes out to be the given function itself. Now coming to another one, fifth. You can see 3 functions are defined here. We have to check which one of them will be having inverse. This one we came to the inverse using composition of functions. Here I will use the other definition of making out whether the inverse exists or not. We also know if the function is bijective, then the inverse can be found and we can say the function is invertible. So we have to quickly see if these functions are 1, 1 as well as onto or not. So you can find f is having 1, 2, 3, 4 in the domain and 10 in the domain, codomain. And see how the pairs are being defined. F is having, 1 is having image 10, 2 is having image 10, 3 is having image 10, 4 is also having image 10. So what do we see here? F is many one function. F is a many one function with, see, many elements in the domain having same image. F1 is equal to F2, which is equal to F3, which is further equal to F4, which is equal to 10. This means F is not bijective, hence not invertible. Is not bijective, this means F is not invertible. Then moving on to the next one, look at the elements of domain of G and the elements in its codomain and how they are being paired. So you quickly see if there are more than two or more elements in the domain sharing the same image. If yes, then this also becomes a many one function. So 5 has got image 4, even 7 has got image 4. So due to the same reason, this function will not be invertible. We can say G is many one function with two numbers, 5 and 7, having same image. G5 is equal to G7, which is equal to 4. Fine. So therefore, G is not bijective, hence not invertible. Hence not invertible. Then see the last one. Okay, when we come to the function H, 2, 3, 4, 5 are the elements in the domain, 7, 9, 11, 13 in the codomain. Let us see the images of the elements in the domain. 2 has got image 7, 3 has got image 9, 4 is having image 11 and 5 is having image 13. So what do we see? Different elements in the domain having different images. So different elements in the domain have different images, have distinct images or different images, you can say. This means what? This means H is 1, 1. Okay, so it is 1, 1. Now we need to check whether it is onto or not. What are we going to verify for the function to be onto? We will see that every element in the codomain, for every element in the codomain, there is an element in the domain. Or you can say every element of the codomain is an image. So we can write as each element of codomain is image of some element in the domain. Therefore, it is onto. Now you can see it is 1, 1 as well as onto. That is why it will be invertible. This implies H is bijective and hence invertible. So we need to see whether the function satisfies the condition for 1, 1 and onto function. If yes, it will be bijective and therefore it will be invertible as well.